Hey everybody, PCB Junkie here. Today I'm going to show you how to change the battery inside of a Tektronix TLA 704 logic analyzer. The common problem with these when the battery dies is that these units will no longer boot up. So let's power this guy on and see basically what happens with this fault. As you can see, you'll have a message complaining that the system battery is dead. If we decide to continue, if we hit F1, where is it? F1. What's going to happen next is that the unit will complain that the operating system is not found. That's not actually true in this case. This unit does have a hard disk, as you can see right here. It's a 2 gig disk, but with a dead battery, this is basically as far as these will go. So in order to fix it, the only option for you is to go ahead and replace the battery. Unfortunately, the battery is embedded inside of a real-time clock chip. It's not easy to get into. We're gonna have to do a little bit of cutting, but I'm gonna show you a quick way that I found to get to it, causing minimum damage. In order to change the battery in this unit, we're obviously going to need a battery. This is a CR2032 battery, fairly common. You should be able to get this in dollar stores. Pretty much anywhere they sell these types of batteries. Very, very common. It's a battery holder. It's a through-hole mount holder. Again, fairly common. You should be able to get this from eBay or any type of electronics store. Maybe salvage one from an older motherboard. Yeah, it's the type of holders that are used in old computer motherboards. Pretty easy to get. Some crazy glue. Gonna need that to mount this holder onto the real-time clock chip. In order to get into the unit, gonna need a Torx screwdriver. This is a T15 Torx. It's the small tip. Pretty much all the screws in this unit require this type of screwdriver. What I have here is a scalpel. It's got a fairly pointy end. We need this to cut the lead of the existing battery inside of the chip. There's not going to be a lot of room, so we need something with a fairly pointy end. You should be able to use something like this, or maybe even a small X-Acto knife. I'll show you how to get in there. Found a pretty easy way to get rid of that, to disconnect that lead from the old battery. So that's gonna come in pretty handy. I got a multimeter here as well. Not necessarily required, but it's gonna help us to make sure that the existing battery has been disconnected from the unit itself. And finally, what I've got here is my old Heiko clone soldering iron and some solder. Let's talk a little bit about this tip here. So it's a wedge type tip. It actually is very useful for what we're about to do. Try to get something with a smaller tip. It doesn't really matter all that much. I mean, it's not a precision work that we're attempting here, but smaller the better. It's just going to be easier to get into that chip and replace that battery. Okay, so that's it, and now we'll just start to disassemble the unit. I have the unit standing on its back feet in order to take the bottom panel off. That's the first thing that's got to come off. There are 4 screws holding it down. There's one up here, there's one down there, another one here, and one up here as well. So before you do this, just make sure everything's unplugged. Certainly we don't want any power going into it. This plug, even though it's attached to the side of the unit, it's not actually plugged into the wall. So we're gonna take off the screws here. Remove the bottom panel, put it aside. I flip the unit over in order to remove the top panel. We have 4 screws holding this one as well. One here, one over there, and one over there. These clips here, these 4, were used to hold the probe pouch. If you have one, obviously you're gonna have to remove it in order to get to the screws, but maybe there's a way to get around. I'm not sure. This unit never came with one, so I'm not completely sure whether you need to remove it or not, but just make sure you can get to these screws and unscrew them to take the top panel off. And let's put this one aside as well. With the top and bottom removed, the side panel should be very loose and should just probably come off by pulling down on it. Let's have a look. Yep, that was pretty easy. With the plastic side panel off, we're exposing the side of the unit where the motherboard is. It's actually held behind this aluminum panel right here. These vents here are for the Pentium 166 CPU. You can see the heatsink right behind. And this panel, in order to remove it, we have to unscrew the 3 screws on the side here, another 3 on this side, and the 2 up there. And then the panel has to be pulled back from the top here. And then, as you can see, there's this little tab that's holding it in place. So once the top comes out, we'll lift it up and it should come out. Okay, so let's give that a go. Now all the screws, they're all the same. So there's no need to worry about mixing them up. They're basically the same screws, same depth, same size screws. So I just put them all in one pile, and hopefully by the time I'm done, we're not going to have any missing or any extra. Okay, now for the tricky part. There is a little space up there where we can insert something, and that should give us enough leverage to push the panel out. And now we're able to pull it out like so, and it should hopefully come out with no trouble. Put this one aside. So here's the logic analyzer motherboard. The chip that we're interested in is this guy right here, a Dallas DS or 12887 Realtime Clock chip. Inside this unit, there's a battery, probably a very similar type of battery that we're going to be using. The battery leads are actually coming out, and they're traveling on this side of the chip, which is very convenient for us. And we'll be able to open this part up and intercept these leads. Actually, there's one here, which is the positive side, and there's one here, which is the negative side. We're going to be able to cut in, intercept it. We're going to cut one of these traces off. We're going to cut off the negative one. It's just easier to deal with. And we're going to install our own battery. This holder, it's important to mount it on the side like this. And the reason for that is this board, or this panel I should say, right here, it has these notches, and basically when this panel goes into the unit, the notch right there is actually almost hitting the chip in the spot. So if you straddle the battery across the chip like this, you may find that you won't be able to close the door. So I don't recommend doing it this way. This is probably the best way. Yes, I mean, it's not held 100% securely this way. Half of it is exposed, but no one's going to be coming into this unit for a long time after this battery's changed. So that's a pretty safe way of doing this. Now what I normally do, and this is completely optional, but once we put the grooves into this chip and solder this battery holder in there, I like to use epoxy and just basically close everything up. So the crazy glue and the epoxy is going to hold this pretty well in place. Nothing to worry about. Alright, so I'm going to put the camera on a tripod and we're going to start cutting into this guy. Alright. So right now I'm waiting for my soldering iron to warm up a little bit. A couple things to take note of. These chips down there, I mean, they're not exactly super fine, but the legs are pretty close together. If anything slips, chances are you're going to poke right into there and make a big mess. Just keep that in mind. You may want to use some sort of a layer of protection, just maybe some tape, or I'm not sure, something to protect it if you don't have good steady hands. I don't, but I mean, my hands shake like crazy, but should be able to do this, no problem. Just gonna be extra careful. And what I want to do, because I'm gonna be installing these legs right here. These legs are gonna be installed like this, and we're actually gonna be pushing them into the meat of the chip. I'm going to put a notch into this chip where the legs are. I'll also bend the legs a little bit inwards, and we're going to solder a little bit of an extension. Here it goes. So basically, initially, because of how the legs on the battery holder are slanted, we're going to come in, we're going to put a groove in this direction, and then we're going to turn it, basically follow this path where this pin is missing to intercept that lead, and there's the other lead should be over there. So we'll do the same thing. We'll come in this way and we'll bend our path in order to intercept that lead. Alright, so here it goes. I'll cut in. Basically we're burning the plastic off. This is this plastic here, it's going to be a little bit smelly. This outer layer, it's hard glass reinforced plastic, glass fiber reinforced plastic. It'll make a noise when we get in there with the soldering iron, but underneath that is some sort of a different type of compound, which is very soft and easy to cut into. All right, let's make it happen. I'm going to clean up that mess afterwards with an X-Acto or the scalpel. As you can see, there are the two layers. So we got through the first top layer, and then underneath is kind of like this powdery filling. I'm not sure what it is. Some sort of a potting material. Pretty easy to scrape off. I mean, you could do this with a Dremel as well, or even cut it with an X-Acto knife. What I don't recommend though is that you use a Dremel while cutting into the metal right here, because I mean there's a lot of chips out there with tiny legs, and if you get a little bit of dust between those legs, you may run into some trouble. So best thing is just to basically burn this off with a soldering iron. Since we're going to be using one anyway to solder the battery, I mean, it just makes sense. So that's what I found useful. It's a little difficult to get in there with the tripod being in the way, but I'm doing my best. Need more heat. So basically just keep digging until you get to the metal trace. Oh, not really a trace, it's basically the battery lead. And I think I got it. Okay, so we're going to clean this up and see if we can expose it. So I can already see the battery lead on the negative side here. Not quite there yet on the positive side, so we'll just keep going a little bit more. And I think I got it. So yeah, if you just push hard enough, eventually you'll get to it. I mean, it's there. You can't miss it, right? As long as you're in the right spot. And like I said, that spot is between this gap right here, between those two legs, and also on this side where that leg would have been if it was there. I'm gonna pick up the camera and show you in a second what this actually looks like. Now that I've cleaned off the grooves with cotton ball and a bit of moisture, I can very clearly see the battery leads on both sides. This one, the positive one, is a little bit shorter, and the negative is a little bit longer. However, it does dip into the potting material at this point here. I'm not sure if it's very clear on the camera or not, but basically the next step, which is probably the trickiest step in the whole procedure, is to cut this trace and sever it from the chip itself, sever the battery from the chip itself. The reason for this is because when the new battery is attached, it's just going to try to recharge the old battery, which is not what we want. We want to completely disconnect the old battery here and have our new battery supply the SRAM that's within this chip. So the quickest way I found for doing this is basically putting the scalpel or X-Acto in a space between that lead and the potting material. Okay, and basically just rocking it back and forth, pushing on the side of the potting material in the case of the chip to basically tear into that metal. can already feel it going in. Okay, I think that's it. Get a close up. So as you can see, that lead right there is actually now separated from the rest of the battery. So we're going to lift it up just a little bit. Make sure that when we solder, there's no chance for the new battery holder to make contact with the old battery. Okay, that looks pretty good. Alright. Before we do any soldering, let's quickly have a look at the voltage of the old battery. And we're getting 1.05 volts. Okay, so next, just to be certain, we'll put the meter on resistance, actually continuity. Now let's check between those 2 points, and there is no connection there. So that's exactly what we want. So now we're going to tin those 2 terminals, get them ready for a new battery holder. This is a bit tricky. If we warm this up a little bit too much, it'll start melting the plastic and messing up the area. So we'll try to get good contact and a lot of heat on this pad before we apply solder, and hopefully we'll get it on a first try. Okay, that worked pretty well. Let's do the other one. This should be easy, given how it's lifted off the potting material a little bit. Should be easy to heat up. Okay, so that looks pretty good. Now I also have to make sure that the terminals are in the correct position. What I mean by that is that the positive and the negative are not reversed, and looking at the battery, I can confirm that the edge of the battery and the top is positive, so it should be on the left, while this side here, the underneath, should be connected to the negative, which is on this side. So actually we have to apply the glue to the bottom, or this area of the battery holder. So let's do that. And let's stick these 2 together. So the next step will be to solder the battery holder leads to the old battery terminals within the chip. Now the space is quite small, so I had to move the camera back a little bit so I can get in there and do this without making too much of a mess. Okay, should do it. Let's have a look. It's really tough to get the camera in there, but yeah, there it is. Doesn't look too bad. Just as an added precaution, we're going to put some epoxy in there, some epoxy putty into those holes, fill it in, and make sure that the battery terminals are solidly attached to the rest of the chip. I installed a new battery into the battery holder, and I attached the keyboard to the side of the unit. So now let's power up the logic analyzer and see what we get. The battery bad error that we had before is no longer there. It's been replaced by a system CMOS checksum bad error, which is expected with a dead battery. So we'll run our setup by hitting F2 and load defaults. So we select continue. One thing we have to do as well is detect the hard drive that's installed in the unit. So there it is, 2017 megabytes, and we'll go to save the changes and exit, and hopefully this should get us a working unit that will be able to boot into Windows. All errors are gone, and there we go, Windows 98. So even though the hard drive is intact, the operating system is fine, when these units die, or I should say the battery within these units dies, that's the symptom you should be expecting. The unit will not boot up. It'll complain that it doesn't have an operating system. I believe it's got something to do with the fact that the disk settings cannot be stored. If you change a hard drive and boot these up without doing a hard drive detection, you'll get the same error. It'll complain again about not being able to load the operating system. So that's obviously not the problem. And like I said, the battery, when it dies, gives you the same symptoms. So replace it. It's not that difficult. Does involve a little bit of precision soldering, but for most of us that's not a big deal, and you'll have a working unit. So if you enjoyed this, video, let me know. Give me a like, or subscribe, or just comment, tell me you like this sort of thing, and I'll try to do more. Okay? Alright, so everybody, thank you so much for watching, and we'll see you on the next one. Bye now.